Okay, in this problem, we have a segment that's bisecting an angle, and then the same segment, see those are the same, they're just written backwards, is bisecting a different angle. So there's nothing congruent in the given information. So BD is cutting this angle into two equal pieces. So angle ADC is the angle over here. So I'm going to mark that those two angles are the same. Then it's also cutting the angle over here into two equal pieces. I can't use one arc because I just did that already, so I have to use two arcs in each of those. Okay, so that's the only information we have in the given. I can also see that these two triangles share a side, so we can mark that that's congruent to itself. So we have two angles and a side, so once again it has to be one of these. If I put my fingers on the two angles that we marked in this one triangle, this side is between my two fingers, so that means we're going to use the S in between the A's. So this is ASA. Okay, so step 2, let's define the information they gave us, this bisect, that word in the given. So first we mark that these two angles were congruent because the segment is bisecting that angle. So angle CDB is congruent to angle ADB, and that is the definition of bisect. Okay, so now in the next step, I'm going to give the two angles that are congruent because of this statement here. And it's also going to be because of the definition of bisector. So I don't actually have to write a 3 here. I can include that information under step 2. So that is these two angles that are equal to each other. Angle CBD is congruent to angle ABD by the definition of bisector. So I just said that two different angles were congruent, so let's mark off the A's. Now all I have is the sides that are congruent. So that side BD is congruent to itself, which is the reflexive property. You mark off the S. I've marked off everything in my to-do list, which means my last step, you can use the prove statement. Triangle BCD is congruent to triangle BAD by ASA.